Do you still remember Diggy's case from the S Company in the last video? Let's find out what he do after he upgraded Jennifer to the newest version and used Stack Trace to help him find out the problem with his application. From the last video, we know that Diggy has an app called Backend App. He monitors his app with Jennifer APM and finds that there is a not profiled area in the detailed XView pop-up window. After one of his work team, Cindy, tells him to update Jennifer APM to the newest version, he then configures Jennifer APM so that he can analyze the not profiled area in the Stack Trace, one of the Jennifer APM features that have been renewed in the newest version. Now, let's see how the Stack Trace can help Diggy find the problem of his app. He drags from the scatter in the XView chart to open the XView pop-up window and goes to the Not Profiled area in the Timeline tab. Diggy clicks the Stack Trace and clicks Find the Stack Trace, then the screen shows the Stack Trace of the transaction. From the screen that shows up, there are two different colors shown in the front of the time of the Stack Trace. The different colors indicate the type of Stack Trace. If there are sections connected in the same color, it means that they are collected consecutively, and it means that it has been running for a long time. In other words, it is a slow method. In Diggy's case, the blue color is collected many times, and it's a sign that the method is what makes the response time so slow. Diggy then tries to see the Stack Trace in that blue color. Diggy finds that the transaction calls the java.lang.thread.run method up until the java.lang.string.intern method. These methods are called consecutively, and it shows by the blue color section, the collected many times. It means that these methods are slowing down the app. The Stack Trace also shows when the time of the transaction happens. Diggy then checks the Summary tab. It shows a tree obtained by integrating the call relations of each method shown in the Stack Trace collected. The slowest method is shown by the bar that occupies the largest size area. In this case, the string_intern method occupies 84.12%. In terms of time, it took about 5.3 seconds. Diggy checks again in the Flame Graph tab. The colors indicate the same package. The slowest method is the one at the top of the square area, which is the string_intern method. From that information, Diggy can know that the string_intern method is the method that he must improve to make the response time faster. But what is exactly the string_intern? Diggy then searches the information from javaperformance.info for Java Performance Tuning Guide. String.intern is a native method that is provided by basic JDK versions. If the text string sent as a parameter to the text string pool managed by JVM does not exist in the text string pool, then it is inserted before being returned. Otherwise, if it does, then it is returned after finding a match in the text string pool. Simply put, it prevents duplicate generation of the same text string, thus reducing the memory usage rate. Because Diggy uses JDK7, from the information that he got, he assumes that the default size of the text string pool is 1009, and as text strings exceeding the size are accumulated, adequate hash distribution keeps failing. Unless the data within the map is distributed by using a proper hash algorithm, the more the data the slower the viewing speed gets. If this is the actual cause of performance degradation, he can expect some performance improvement simply by increasing the text string pool size. He set the text string pool size in the backend app scripts as follows. The size is the same as the default size of JDK8. After finishing, he restarts the backend app and tries to monitor once again using Jennifer APM. Now, the XView chart shows that no transaction takes a long time anymore. The transaction becomes faster, and Diggy can now tell the manager that the app is ready to use. So, that's all about the renewed Stack Trace by looking into Diggy's case. If there are transactions that are shown as not profiled in the XView pop-up window page, developers can now find the problem with the newest Jennifer APM version. Jennifer is also preparing an analysis function based on the Stack Trace of the entire system beside the Stack Trace of individual transactions. The function will greatly help you in resolving performance issues that cannot be analyzed from the transaction perspective. So, you may be full of high anticipations. See you again in another video. Thank you very much.